Let's say you see this giant elephant sprinting across a field, and one guy says, "Wow, that elephant has a lot of momentum." Well, he's right. Since momentum is defined as the product of mass and velocity, and the elephant has a large mass and a non-zero velocity, then yeah, that elephant has a lot of momentum. And probably the most important thing to take away from this video is that momentum is a conserved quantity. The easiest way to understand this is to relate it to other conserved quantities like mass and energy. We already know that in a closed system, mass is neither created nor destroyed. If we have a plastic ball just sitting on the ground, even if we leave it for a long time, it's not going to spontaneously create mass and get bigger, or destroy some of its mass and get smaller. Same thing with energy. It's always transferred, not created or destroyed. And so we can apply the same idea to the momentum of a system. Let's visit that elephant again and see what he's up to now. Well, the elephant is sprinting so fast that he bumps into another one that has the same mass. Surprised, the second elephant begins moving at the same speed that the first one was going at, even though the first one stopped. Well, what happened here? So since the momentum of the system is conserved, then the initial momentum has to equal the final momentum. We'll just say that both elephants have a mass of 5,000 kilograms. At the beginning, the first elephant was traveling at 6 meters per second, and the second elephant was standing still, so his velocity would be 0 meters per second. The total initial momentum of this system would then be the combined momentum of both elephants at the beginning. So mass times velocity for the first elephant would be 5,000 kilograms times 6 meters per second, and mass times velocity for the second elephant would be 5,000 kilograms times 0 meters per second. Now we can write out the final momentum of the system. The first elephant stopped, so his velocity is now 0, and the second elephant now moves at the same speed that the first elephant was going at the beginning. So the momentum for the first elephant is 5,000 kilograms times 0 meters per second, and the second elephant is 5,000 kilograms times 6 meters per second. The initial and final momentums are equal to each other, meaning that momentum is indeed conserved.